Alright, welcome back ladies and gentlemen. In this video we are going to talk about converting from rectangular coordinates to polar coordinates, as we are still in our unit all about the polar coordinate system. A couple things to keep in mind as we get going on this video. Understanding that when we do convert rectangular coordinates to polar coordinates, we're going to have to realize that there are infinitely many possible polar coordinate pairs that could happen. And that's basically the idea of going around and around a circle over and over again. Every time that you add the 2 pi radians to it, you are basically going to end up at the exact same spot over and over again, even though you could change the different values of the direction angle. So let's take a look here at this example of converting from rectangular to polar coordinates. A couple things to keep in mind is remember that if you're thinking about our reference triangle now has a Pythagorean theorem that says x squared plus y squared equals r squared. And then we also need to know our ratios of our basic trig functions. Understanding that the cosine of theta, of course, is x over r. Understanding that the sine of theta is y over r. And understanding that the tangent of theta is y over x. And so all of that is going to help us in conversion from rectangular to polar coordinates. So in this first example here, we are looking at a regular coordinate of -1, 1. And we want to go ahead and transfer that into polar coordinates. So let's kind of just plot this point first and foremost. Obviously, we know -1, 1 is going to be over here in quadrant 2. So here we are, -1, 1. And we want to change that guy and make that into a polar coordinate. So if you think about this, obviously, we have ourselves -1 in the left direction, +1 in that vertical direction. And then we can always find out what that radius is going to be. We're also going to call it the term modulus later on, or you want to think about it as the hypotenuse of this reference triangle. We can always go ahead and find out what that guy is first and foremost. And so we know that we have -1 squared plus 1 squared is equal to r squared. And so we see that we have 1 plus 1 equals r squared, therefore r is going to be the square root of 2. And this is good, because if you remember, our goal is to start getting r's and thetas into the mix, because that's what the polar form is going to be. Alright, so we know x, we know y, and of course now we know r as well. And so now we can go ahead and use any of our cosine, sine, or tangent functions. You just have to keep in mind as to where are we in our actual quadrants. And so in this case here, we're in quadrant 2. So I'm going to go ahead and utilize the cosine, because in this case, cosine, you don't have to worry about adding pi or adding 2 pi or anything kind of like that to it, because the restricted domain for cosine inverse is from 0 to pi. And so we kind of take care of all of that by using cosine. So we know that cosine theta is going to equal to -1 over square root of 2. So really that means that theta is going to end up equaling let's see, your cosine inverse of negative square root of 2 over 2. So theta in this case is going to be, think about it, you're in quadrant 2, where is cosine inverse going to have a negative square root of 2 over 2? And that's going to be at 3 pi over 4. And so that kind of helps us understand the beginnings of where we're at. So let's think about this. I have the point, -1, 1. From there, I want to convert it to polar form. So now that point is going to be radius comma theta. So the radius was square root of 2, and then I have 3 pi over 4. But we have to keep into account that if we had a negative radius, then we would just have to basically turn that over and add pi to our 3 pi 4. So we just got to be a little bit cautious when we are doing these guys here. And so instead we could also say that there is a point P at negative square root of 2, and then have 3 pi over 4 plus pi. So really it's 3 pi over 4 plus 4 pi over 4. So that ends up being 7 pi over 4 there. And so in both of these two cases, we end up getting our polar coordinate. Now, in the other one that we're going to kind of talk about here is part B. So now this is a very interesting example that comes up. So in this example here, we see that, well, when we have a point -3, 0, where are we? Well, we're actually on the x-axis. So this kind of provides an interesting scenario for us. Because at this point in time, if you are on the point -3, 0, where are you on a unit circle? Well, basically you have a unit circle that's been scaled by a factor of 3, right? That radius of 1 is now being a radius of 3, regardless of the sign of the value. But when you're on that point -3, 0, you're really at pi radians. And so if you're going to convert this guy into our polar coordinates, well, where are we? Well, we're right there at -3, 0, but that's really a radius of 3. And then we're at pi radians. But since you have to account for that negative radius as well too, here we are at 3. And at 3, we're going to have 0 degrees. And so we also have -3, 0 being there. And it's literally just because going back and forth, it's going to keep bouncing it back from positive to negative, positive, negative for that radius.